Hey, in this concept, we're going to divide a polynomial by a monomial. And so as we do this, there's a couple steps that you can follow, and they're listed at the top in your notes and listed on screen. The first thing we try to do is we split the problem into pieces by placing each term in the numerator over the denominator. Second, we try to simplify each of those terms, and we use our properties of exponents to reduce each of those fractions. Now, there are times where the monomial divided into the polynomial won't quite work the way you want it because you end up with a little bit of a remainder or a variable in the denominator. And so let's talk about the steps here. So let's do that in A. So the first thing we want to do in A is this. We want to go ahead and write 6x to the fourth and put 2x squared underneath it. So what we're going to do is we're going to divide each term by 2x squared. All right, so now we reduce using fractions and using exponent rules. So 2 goes into 6 3 times. And x to the fourth, remember, means there are 4 x's in the numerator, but only 2 in the denominator. So what we can do is we can say, all right, these 2 x's and these 2 x's can cancel themselves out. And the reason why is you have x squared divided by x squared, which is just 1. That leaves us x to the fourth over x squared, which is just x squared. So again, we're left with x squared in the numerator. So that's all we'll have. The second part, I know it's going to be negative, and 2 goes in 8 4 times. Now I have 3 x's in the numerator and 2 x's in the denominator. So I'm going to have 1 x left in the numerator. And finally, the last part. 2 goes into 12 6 times, and x squared divided by x squared is 1. So we have divided this as far as we can go. Let's look at B. So let's do the same thing. We have 24x to the fourth, and we'll put negative 6x squared underneath. We have minus 16x squared over negative 6x squared. So negative 6 will go into 24, negative 4 times. We have an x to the fourth over x squared. That's going to leave us with an x squared. Negative divided by negative on the next part is going to give us a positive, and 16 over 6, well, what you can do with that is you can reduce that down to positive 8/3. And x squared over x squared is just 1. Now, there's another thought with this, and I'd like to share it with you right now. Because when you divide, that answer is fine. But when you divide, what you have to look at is you have to look at what all of these have in common. So let's think of it that way. All right. Well, 24, 16, and 6 can all be divided by 2. They can't be divided by 3. They can't be divided by 4. So if we divided each of these by 2, that would give us 12 and 8 and 3. Now the other thing is they all have an x squared. So if we take an x squared out of everything, here that's going to leave us an x squared. So now we still have this negative, these negative signs kind of floating around, don't we? So negative here, negative here. So let's put everything we have left together. That would make it 12x squared minus 8 over -3. Now, if you take a look at these answers, are they the same? Well, if you put -3 with both of these, would we end up with -4x squared and positive 8/3? And the answer is yes, we sure would. So moving forward, the first step as far as putting the monomial underneath both is absolutely something that you want to do. As you move forward in math, one thing that you can think of is your situations are going to become more complex. And so sometimes it's a little bit easier to think, okay, what do all the terms have in common? And remove that common term, kind of like it's called the greatest common factor of everything. And so once you take that greatest common factor out, you'll see you'll get a little bit different looking answer, but in the end, it is indeed all the same. Let's look at C. Okay, with that being said, if we look at C, we have a 3. And 3 would go into 18, 3 would not go into 22, and 3 would go into 15. So, in a situation like that, what do we do? Well, one thing that we can do is we could leave this be, because 3 doesn't go into all 3 terms in the numerator. That's an option. But what we're really trying to get you to do is reduce every term as far as possible. So if we take the 3 and put it underneath both, and then that middle one as well, we're going to end up with 6xy. And since 3 won't go into 22, we could write that as 22/3 x cubed y. And 3 will go into 15 5 times. So by division, by dividing each term by 3, that's what we arrive at. Now, if we had common denominators with everything, we would get right back to where we started. So since we're really working on that division, that's how we can divide each term by 3. And let's do it with the last one, D. So here's 12x cubed y to the 4th, 2xy, 6x squared y squared, 2xy, and 4xy over 2xy. Okay. So if we take a look at this, 2 goes into 12 6 times. I have 3 x's, or x to the 3rd in the numerator, and 1 x in the denominator here. So I have an extra 2 x's, or an extra x squared in the numerator. And because I have y to the 4th over y, I have y cubed left in the numerator. So for the next part, 2 goes into -6, -3 times. I have an extra x and an extra y in the numerator. X squared divided by x is x. Y squared divided by y is y. Finally, the last one. 2 goes into 4 twice. X divided by x is 1. Y divided by y is 1. All right. And so that's the steps into how we want to divide a polynomial by a monomial. All right. 2 for you to try. Take a look at these. Now, again, the strategy that you can use is you can put the 4m cubed on number 1 underneath all 3 terms, or you could just think, if I divide each of these by 4m to the 3rd, what will be left? So try number 1 and try number 2. Pause the video, do that. Here are two answers. We have m squared plus 3m minus 6, and we have 2r squared s squared plus 3rs plus 2. It's kind of fun. You're using exponent rules along the way, and you are using some properties of fractions together to simplify. Now, what you're able to do after this video is you're able to add, subtract, multiply, and divide polynomials, specifically with monomials in the division part, which means you can find the sum, difference, product, and quotient of polynomial expressions. Pretty cool what you can do, and pretty amazing what we're going to be able to do with those as you move along in mathematics too. Thanks for watching. See you next time.